Yes, good morning, students.
Good morning, sir.
Morning.
Good morning, sir.
Yeah, very good morning. So, in the previous class, we have discussed about what I think I solved one example on how to uh, do the signal constellation diagram, right? How to draw the signal constellation diagram and how we can express the signals, that is Si of t, as a linear combination of the basis functions. And then I think I discussed about synthesizer and analyzer. Okay, hope remember. Yeah, still
Sir.
I opened that. So this is known as the analyzer. I think earlier to this told about the synthesis, right? So any one of you, is it possible to say what do you understand from this synthesizer? I said because it synthesizes the transmitted signal by a bank of n multipliers. That is what is called synthesizer. So how you correlate this? Here SI1, SI2 and so on up to SIN, you can think of the message signals. Okay, I have n number of message signals. Okay, then this pi1 of t, pi2 of t, pi n of t are all the carrier signals, I can say. See, by multiplying, I get a modulated signal, right? So I am adding all those and I am sending the cumulative modulated signal, I can think, Si of t. Okay, so Si of t is a modulated signal. Okay, so here I have n number of different message signals. Each message signal I am multiplying by different carrier frequencies. See, these basis functions are nothing but carrier frequency. Okay, pi1 of t, pi2 of t, pi n of t. Fine. Hope got my point. And next is analyzer. I said, na? Analyzer, what we do here is we give that signal, modulated signal, as an input here, Si of t, right? Again, we need to get back at the receiver side the original message signals. No? So to get back that, what I do here is I multiply this received signal by a basis function, that is carrier, right? So pi1 of t. Then I integrate over the interval, that is symbol interval 0 to t. So this multiplier and followed by an integrator is known as a correlator, I said. Right? So output of that will be my SI1. Similarly, SI2 and so on up to SIN I get. So this is the standard block which you all find in the receiver part. Okay. So correlator means the received signal will be multiplied by the corresponding basis function. Then you integrate over the interval, symbol interval, to get back the original message signal. Hope you are able to understand at least now what is synthesizer and analyzer. So when we are discussing about modulation and demodulation part, so this the demodulator first block will be this. Received signal will be multiplied by a basis function, then there will be an integrator. So that together we call it as a correlator, I say. That is why I'm stressing more on this. Okay, again and again, I need not say. If I say what is correlator, in your mind it should come. Correlator means it will have two things. One is multiplier. So for that multiplier, one input is the modulated signal, another input is a basis function, that is carrier. Then output of that will be integrated over the symbol interval. So that together is known as a correlator. Okay, hope you will be able to say in future if I ask what is correlator. Yes, my dear students. Will you be able to say what is correlator? Yes, am I audible? Hello?
The multiplier followed by an integrator.
Yes, correct. Multiplier followed by an integrator is a correlator. Yeah. Yes, shall I pick up the next one? Okay, so today we'll discuss about how the energy of the signal is related to uh, the what I can say, the squared length of the signal, squared length of a signal vector. So it is also an important concept, what I can say, to understand. Okay, so let me start with this. I hope you all understood what is n-dimensional Euclidean space. Any one of you can say what is n-dimensional Euclidean space quickly? Euclidean space, n-dimensional Euclidean space, I'm asking. Yes, Pooja, can you say what is n-dimensional Euclidean space? Pooja. Yes, what about Prajwal? Prajwal? Hello? Hello, I am audible. People are not responding. Prajwal? Hello?
Yes, sir. Yes, sir. Now we can hear. Now,
Yeah. Yeah, can you just say what is n-dimensional Euclidean space? What you have understood? N-dimensional Euclidean space.
sir, it is a signal space.
Ah, yeah, signal constellation diagram. Fine. How do you define that? As I said, SI, right, is a signal vector. Okay, it can be considered as a point with coordinates. What coordinates? SI1, SI2, and so on up to SIN. Okay, SIN in an n-dimensional Euclidean space. Okay, means the signals S1 of t, S2 of t, and so on up to Sm of t. Means I have m energy signals, right? Those m energy signals can be considered as m points represented by the vectors S1, S2, and so on up to Sm in an n-dimensional Euclidean space with reference to axes pi1, pi2, and so on up to pi n. And I took the example also, right? I gave three signals S1, S2, S3, and I have mentioned its coordination value also, right? I think, and with that I have drawn how I represent S1, S2, S3. Hope this point is clear. Still people are not able to say what is signal constellation diagram. So that n-dimensional Euclidean space is known as the signal space, and the representation of signals in an n-dimensional signal space is known as the signal constellation diagram. Okay, so to continue with that, if I consider an n-dimensional Euclidean space, okay, in an n-dimensional in an n-dimensional Euclidean space, here I wanted to relate the energy of the signal and the signal vector length. Okay, that is my motto. So in an n-dimensional Euclidean space, the squared length of any signal, the squared length of any signal vector, squared length of, yeah, the squared length of any signal vector, squared length of any signal vector, that is what? Si. Okay, signal vector is Si. The squared length of signal vector is given by the inner product, is given by the inner product. I hope you all know what is inner product. How do you find the inner product? Yes, inner product is given by the inner product, or I can say dot product. Inner product or dot product of the signal vector Si with itself. Yes, what do you understand by this? I said in an n-dimensional Euclidean space, the squared length of any signal vector, Si, okay, is given by the what? Inner product or the dot product of the signal vector Si with itself. Means how do I write this mathematically? See, I know how to write the length of a vector. Any idea how do I write the length of the vector? See, I can write the length of vector, Si. Okay, usually I denote that by what? With this, right? Two parallel lines I write, and I can write Si. This is the way I represent the length of the vector, length of the signal vector Si, right? And what I said here, the squared length of any signal vector, okay, is the what? Inner product or dot product of the signal vector with itself. So what I can write is the squared length, right? I can say Si square length, it is right. So Si squared, which is equal to what? Inner product I said, right? Inner product or dot product I am said. So usually I write the inner product, this is Si transpose into Si. Okay, Si transpose into Si, or I can say Si comma Si. So square length of the signal vector is the inner product or dot product of the signal vector with itself. So this is how I represent mathematically. So I can write I know what is SI, right? And the value of I can vary from 1 to m, right? So I can write, if I write this SI by like this, right? SI1 is a row matrix, then SI2, then SI3, and so on up to SIN. Okay. And the transpose of this will be what? It will be a column vector, right? So I can write that with the column vector. That is, I can write here SI1, then SI2, and so on up to SIN. Okay, the square length of the signal vector, I said it is equal to inner product or dot product of the signal vector with itself. I can represent mathematically the squared length of the signal vector as like this. I am just representing that in the form of row matrix and column matrix, right? Then if I multiply these two, what I get? Yes, I think this much people can say, no? I have two matrices. One is row matrix, another one is column matrix. If I multiply these two matrices, what is the result? Yes, what can I write? Hello? Yes, Sovik Roy, can you say? See, I have written two matrices. One is row matrix, another one is column matrix. Row matrix is from SI1, SI2, and so on up to SIN, and column matrix is SI1, SI2, and so on up to SIN. If I multiply those two, what can I write, man? Sovik?
Yes, sir.
Yeah. Is it possible to say what I can write with multiplication of these two?
Sir, SI1 square plus
It is a
SI2 square.
multiplication of, yeah,
Sir,
very good.
SI1 square plus
See,
SI2
SI1
square up
square,
to SIN square.
very good, man. SI1 square plus SI2 square plus and so on up to, I can write SIN square, right? S square IN, right? S square I1 plus S square I2 plus and so on up to S square IN, right? So, which is nothing but what I can write. See, S square I1 plus S square I2 plus and so on up to S square IN. So if I want to write this in the form of summation, what I can write? Summation, right? J is equal to, I can say 1 to n. Is that fine? S I J, that is S square I J. Is it fine? Can I write like this? Yes, can I
Yes,
write like
sir.
this? I'm asking. Any one of you can, yeah, right? So I can say SI square. So this is what squared length of the signal vector can be written as summation j is equal to 1 to n s dot ij. So let me call, I think, what is the equation number? Have I given any number so far? Anyone can say if I am correct, it is equation number 5. If I am right, so I can say the value of I can vary from 1 to m, right? 1 to and so on up to m. Anyhow, the value of j can vary from 1 to n. Okay. And here is Sij. Sij are what? The coordinates of the signal vector Si. Okay. So I can say Sij where Sij are the coordinates of Si, are the coordinates of the signal vector Si. Okay. Yes, hope this point is clear. Square length of the signal vector will be equal to summation j is 1 to n s square ij. Right? I said it is the inner product or dot product of the signal vector Si itself. Okay. Then now let me consider two signal vectors. Okay, and let me try to find out the angle between those two signal vectors.
Sir,
Okay.
can you scroll up a little?
Now scroll up. Okay. Yeah, is this fine?
Yes, sir.
Yeah. So I said the square length of the signal vector is the inner product or dot product of the signal vector with itself. So I represented mathematically like this. Okay. Then I am expressing, means I wrote in terms of row matrix and column matrix, right? When I multiply that, I can write as s square I1 plus s square I2 and so on up to s square In. I wrote that in the simple form, that is in the summation form, right? So summation j is 1 to n s square ij I can write. So where the value of I can vary from 1 to m and the value of j can vary from 1 to n. I said this Sij are the coordinates of the signal vector Si. Now I am interested in knowing what is the angle between the two vectors. That is, if I consider Si and Sk are the two signal vectors, how do I find the angle between those two vectors and how that angle is related to what of the signal? Okay, we need to understand these things which will be helpful in further coming modules. Okay, there is a all mathematical background what I am doing now. Okay. So any one of you can say how do we find the angle between two vectors? Yes, if I consider Si, let me say let Si is one signal vector and Sk is another signal vector. Okay, so these are the two signal vectors what I am saying. So what is the angle between these two vectors? How do I define? Yes, these are, I think you might have studied in mathematics or even in linear algebra, what course is offered in 4th semester.
Sir, we can take dot
Yeah, if I
product of
say,
length of SI vector dot length of SK vector into cosine of the angle between them, and from that we can find angle, sir.
very good, very good. That is the time. Okay. So exactly what Skanda said is right. Okay, if Si and Sk are the two vectors, let me write this, the two vectors in the set, what I can say, then the cosine of the angle, then the cosine of the angle between the two vectors, between the two vectors Si and Sk is defined as I can write cos, okay, cos theta ik. Okay, cos theta ik is equal to, so what I said is, it is the ratio of inner product of these two vectors, inner product of Si and Sk. Okay, inner product of the two signal vectors, that is Si and Sk, divided by length of Si and length of Sk. Okay, I will write with different color, divided by, can say, length of the signal vector Si and the length of signal vector Sk, length of Sk. Okay, so mathematically I can write this as so inner product I represent Si comma Sk, right, divided by, just now I said how do I represent the length of a signal vector. So length of the signal vector Si is Si with two lines, then Sk is this. Okay, so this is what is cos theta ik, that is the angle, cosine angle between the signal vectors I and k, that is Si and Sk. So let me call this as equation 6. Okay, so what I wanted to say here is this cos theta ik. Okay, this cos theta ik is known as the correlation coefficient. We call this as a correlation coefficient. So we call this cos theta ik known as what I said, correlation coefficient. Correlation coefficient. Okay. It is clear. So correlation coefficient, I denote it as cos theta ik, is the correlation coefficient between the two signal vectors Si of t and Sk of t, right? And its magnitude is always less than or equal to 1. Okay, the magnitude of this will be always less than or equal to 1, I can say. So to say the two vectors Si and Sk are said to be orthogonal. Okay, to say the two vectors Si and Sk are orthogonal if their inner product is 0. Okay, if their inner product is 0, then I can say that the two vectors are orthogonal to each other. Hope this point is clear what I said. To say the two vectors, okay, Si and Sk are orthogonal, their inner product should be equal to 0. Okay, two vectors. What are those two vectors? Si and Sk. Two vectors are orthogonal. Okay, to say these two vectors are orthogonal if their inner product is 0. If their inner product is 0. Their inner product is 0. Okay. So with that means here cos theta ik is equal to inner product of the two vectors by length of each vector. Right? So then inner product should be 0, no? To say these two vectors are orthogonal. Then cos theta ik will become what? 0, right? Yes or no? Because Si, Sk, its inner product will be 0. Therefore, I can say cos ik. Cos theta ik will be equal to 0. Then what is the value of theta ik?
90 degrees.
What is that? Huh? It will be
90 degree.
Yeah, it will be 90 degree, right? So therefore, theta ik will be 90 degree. So when angle between the two vectors is 90 degree, then I can say they are orthogonal to each other. Is this point clear? When do I say the two signal vectors are orthogonal? The angle between them should be 90 degree, right? Then I can say the two signal vectors are orthogonal to each other. So here I wanted to correlate the angle between the two vectors or angle between the vectors and what is the energy, okay, energy correlation between the vectors. So just let me write that point. I said angle between vectors angle between vectors is equal to energy correlation between signals. Energy correlation. Energy correlation between signals. Signal. Okay, energy correlation between the signals. So now let us try to relate how the energy of the signal is related to the length of the signal vector. Okay, how the energy of the signal is related to the length of the signal vector. Okay, so I think I asked the definition in the previous class only. How do I define the energy of the signal? Any one of you can say quickly. Energy of the signal. Yes. The definition of the energy of a signal. Let me consider the signal is SI of t. Okay. I want to find the energy of the signal SI of t. Okay. And this signal exists over an interval t seconds. I will write that also of duration t seconds. Of duration t seconds. Yeah, quickly, any one of you can say how do I find the energy of the signal? Mathematically, how can I write? Yes, my dear student should respond. Energy of a signal. Yes, Manasa, can you say? How do you find the energy of a signal? Manasa. Two Manasas are there. One is Manasa SH and Manasa RE. Any one of you can say. Energy of a signal. So Manasa is not here. What about Hima?
Sir,
Yeah.
Yes, sir.
Yes, Manasa, tell me. Yeah, I asked you to define energy of a signal.
sir, is it summation?
I have written here. Yeah, tell me. Yeah. See, definition of a energy of a signal. See, if I have a signal called SI of t and which exists for an interval of t seconds. Okay, how do we find the energy of that signal?
Sir, the x of n the whole square.
Okay, so the energy of a signal, okay, is denoted as E suffix I. Okay, the energy of the signal, SI of t, I'm denoting it as SI EI. So it will be integral 0 to t. Why it is 0 to t? I said that the duration of the signal SI of t is t seconds. That is, I am integrating for the interval. Then it will be square of that, s square I of t into dt. So this is the definition of the energy of the signal. Okay, so let me call this as equation 7. See, energy, power and all, being telecom, you should know how to find energy, power. So where the value of I can vary from 1 to m. So EI is equal to integral 0 to t s square I of t into dt is the definition of the finding the energy of the signal. Okay, so I said this is the definition of the energy of a signal, right? So now just let me substitute what is SI of t. Any one of you can say what is SI of t? I can write SI of t. That is equation 1. In the form of summation, I express it, now. SI of t.
Equals 1 to n Sij Phi j.
Yeah. So integration I write as it is. So I can write what?
Okay, it's going on top.
Summation, right? Yeah. J is 1 to n. J is 1 to n, right? Sij, then Phi j of t. This is just Sj of Si of t, right? So here I have written Si, that is S square I of t. So I can take two vectors. One is yeah. So I can write another vector, that is Si and Sk took, na. So let me write with that summation. K is 1 to n. Then I can say Sik of t into dt. Yes, you want me to scroll up till where?
A little more.
Yeah. Just I started with the definition of the energy of the signal. Yeah, here I wrote angle between the vectors will be equal to what? Energy correlation between the signals. I said that cos theta ik is known as the correlation coefficient. So because of that, I wrote that. So now I am trying to find out how the energy of a signal is related to the length of the signal vector. I started with the definition of energy of a signal. Then I just substituted the value of Si of t, right, as what? Summation j is 1 to n Sij Phi j of t. And similarly another vector I am taking, that is Sk of t, that is k is 1 to n Sik Phi k of t into dt. Okay, is that fine? Yes, S square I of t, I have taken two vectors, one is Si and another is Sk. I am putting k equal to I or I equal to k, but I am splitting here independently and I am writing what is Si of t and what is Sk of t. Is that fine? Yes, is that fine? Or any difficulty in understanding this equation? Just I splitted. I said no, energy of the signal is integral 0 to t s square I of t into dt. I have taken two signal vectors. One is Si of t and Sk of t. I am putting I equal to k. With respect to that, I wrote here S square I of t into dt. So I am substituting here separately for Si of t and another one is for Sk of t. Yes, is this clear? two signal vectors. Okay. So now let me interchange the order of summation and integration. Yes, any doubt with respect to this? What I wrote? This is SI and this is a SK, and I can put I equal to K. With respect to that, I wrote there it is S square I of t. Okay. Yes, don't confuse with this. The energy of a signal is integral over the duration of the signal. By squaring it, I can find out. So here I have considered two signal vectors, SI and SK. That is why I written what I am supposed to write for SI of t and what I am supposed to write for SI of t. Okay, with respect to equation 1, just I wrote in the form of summation. Now what I said, by interchanging the order of integration and summation, what we can write? Let me write this: interchanging the order of summation and integration So what I can write by doing that? Yes, how do I write? We get the energy of the signal SI is equal to, yes, is it possible to say what I can write? I told you interchange the order of summation and integration, means take the summation part outside, then write only the integral part with respect to some variables. What are those? So I take summation j is 1 to n, Sij I will write here. 1 minute. Yeah, I write both the summations, and another summation is what? Another summation is summation is 1 to n. Okay. Summation is k. Summation k is 1 to n. So two summations I have taken it. Then let me write its coefficients. What are those coefficients? One is Sij, and another coefficient is, I can write Sik. Okay, Sik. So summation part I have taken. Then what is left out? Integral part, right? So now I can write integral 0 to t. Okay, integral 0 to t. Yes, what is left out? What I am supposed to write here? Yes, any one of you can say what I am supposed to write.
Phi j of t into phi k of t dt.
Yes, yeah. Phi j of t, right? Phi j of t into phi k of t, right, into dt. Okay. So let me call this as equation 8. Okay, so now let us apply. I said integral, right? Integral from 0 to t. Two orthonormal basis functions, right? That is pi I of t, pi j of t into dt is equal to 1 when I get and equal to 0 when I get. Hope remember that. Yes. That is equation 3, what I wanted to say. Yes, have you remembered that? See the here now, this is what integral 0 to t pi j of t pi k of t into dt, right? So when j equal to k, right, and its product will become what? 1, right? This will be equal to 1 for j equal to k. Then I say it is what? Orthonormal. Means it is having unit energy, right? And when j is not equal to k, then their product over the interval will become 0. Then we say it is orthogonal. Hope this point is there in your mind. Yes?
Yes, sir.
Yes, my dear students, respond. Yeah, integral 0 to t pi j of t into pi k of t into dt is equal to 1 when j equal to k. To say that they have unit energy. And it will be 0, means their product over the interval will be 0 when j is not equal to k, right? So with that, with the orthonormal property of these basis functions, right, what can I write? EIS, yes, when j equal to k, what can I write this summation? Yes, quickly someone can say, when I equal to, that is j equal to k, EI is equal to, what can I write?
Summation j is equal to 1 to n Sij whole square into integral 0 to t phi j of t whole square dt.
No, man, already here it is j equal to k. If j equal to k, then their product will be equal to 1, huh?
Yes, sir. That integration will become 1, sir. Coefficients, it will become Sij whole square.
Yeah, that's it. Okay. So summation, I can say j is 1 to n. Okay, j is 1 to n, and I can write s square ij, because j is equal to k, right? So j equal to k, which is equal to 1. What I can write? Can I write it is Sij? Is that fine? Yes, can I write s square ij? So which is nothing but what? Yes, which is nothing but what? Just now we have derived, no? Summation j is 1 to n s square ij is equal to what? That is squared length of the signal vector. Have I not derived this? Yes? I not come across this expression or what? Yes, people are not responding. I call this as equation 9. Is this fine? I am saying j equal to k, that integral part becomes 1. Then this summation part I can write as what? J is 1 to n s square ij. So which is nothing but what? Squared of the length of the signal vector. So this is the expression how the energy of the signal is related to squared length of the signal vector. Okay. Yes, hope this is clear. Hello. Hello. ಯಾರು ಇಲ್ಲ ಅನ್ಸುತ್ತೆ ನನ್ನ ಜೊತೆ. So this is an important relation, and many times they have asked this proof also. Prove that the energy of the signal is related to squared length of the signal vector. So this is how you should prove. You should start with the definition of the energy of a signal, then you should substitute what is SI of t. You consider two vectors, one is SI of t and one is SK of t. Substitute what is SI of t, you can write what is SK of t. Then interchange the order of integration, summation integration. Then based on the orthonormal property, we can write EI is equal to summation j is 1 to n s squared ij, which is equal to square length of the signal vector. Okay. Yes. Yes. What I can write is the energy of the signal Si of t is equal to what? Is equal to the square of is equal to the square of the length of the corresponding signal vector Si. Square of the length of the corresponding vector Si. So it is an important relation, what I can say. So if I know what is the length of the signal vector, I will be able to say what is its energy, what I mean to say. Okay. Yeah. To continue with this, last equation I will say how this I derived how the energy of the signal is related to square length of the signal vector, right? In the same way, you might have studied about the Euclidean distance also. Okay, if I consider Si and Sk, okay, are the two pair of vectors, right, representing the signals Si of t and Sk of t, then the Euclidean distance, you all know how to find the Euclidean distance? Yes. If I say let Si and Sk are the what? Pair of vectors. Be a pair of vectors. Okay, and these vectors represents the signals. These vectors represents the signals Si of t and Sk of t. Okay, so the Euclidean distance between these two vectors is defined like this. The Euclidean distance. The Euclidean distance between them. You might have studied Hamming distance in ITC. Yes, have you studied or not? ಏನು ರೆಸ್ಪಾಂಡೇ ಮಾಡಲ್ಲ ನೋಡ್ರಿ. Hamming distance not studied, so I can write dik. That is the distance between the two signal vectors. Let me dik is about the distance between the two signal vectors, which is equal to Si minus Sk. And just now I said how EI can be written, right? So again, I don't want to write how EI can be written. I hope you all will be able to write EI is what? Squared length of the signal vector. Since here I have taken two signal vectors, I can write EI as what? EI. What I can write? SI, right, minus SK square, right? And I know what is SI and SK can be written as. Okay. Okay. So with respect to that, I can substitute here for this one to say what is the Euclidean distance between the two vectors as this dik will be equal to, take I think different color, which is square. Okay. So I need to fill something inside this. What I can write is summation j is 1 to n, then Sij minus Skj, this square. Okay, sorry, it is 1 by 2. Square root it is. Just I substituted in terms of the coefficient value. Okay. And if I want to write this in terms of signals, I can write it as integral 0 to t. Okay. Take the square. So Si of t minus Sk of t squared into dt 1 by 2. I can express like this also. Okay. So I think let me stop with this.